In this video, I am focused on the terms and variables associated with motion. This is the first of 7 videos in my Unit 2 titled Kinematics. If you want to practice what is covered in this video, then check out the video description. You can find a link to my worksheet 2.01, as well as video answers for each problem. Let's start with terms related to length. First is position, which will be variable x. This is defined as where an object is. Next is starting position. The variable is x with a subscript 0. The 0 represents a time of 0 seconds. So this is where an object was at the beginning of the problem, or when time was equal to 0. Next, distance. This will be variable d. We'll define it as how far an object traveled, regardless of direction. Distance is a scalar. And then lastly, displacement, which is the variable delta x. Delta in math means change, so this is the change of position. Mathematically, that is the position minus the starting position, and displacement is a vector. Direction matters. All 4 of these terms should be measured in the standard unit of the meter. Let's look at a real-world application. Every car has an odometer, which shows the number of miles that a car has driven in its lifetime. This number either increases or stays the same, but never decreases. So the question is, which of the following motion terms previously discussed is the odometer presenting? Well, I don't think the odometer would tell me the position or the starting position. This number is about how far the car is driven and not about where the car is or where it began. This also wouldn't tell me displacement, since this number only increases or stays the same and never decreases. That would mean that if the car drove forward and then backward, the number would go up and then down, which isn't true. I think this would be defined as a distance. This does not account for direction, and it just calculates the total amount of miles that the car has driven in its lifetime. Next, let's look at a more physics-specific application. This is a style of question that you may see in your class. We have a jogger initially traveling 100 meters to the east, that is the longer vector, and then we'll turn around and run 50 meters back to the west, the shorter vector. The goal is to fill in the values in the chart below, indicating a numerical quantity for each of the motion terms already discussed. Let's start with starting position. That would be where the vectors begin, or where the jogger began. That would be at a position of 0 meters. Next is the position, or the final position. Where did the jogger end up? I think they ended up at a position of 50 meters. What is the total distance that the jogger traveled? Well, they traveled 100 meters, and then also 50 meters. Distance does not account for direction, so the jogger traveled 150 meters. Displacement, we are finding the change of position, the difference between where they finished and where they started. That would be a value of 50 meters, 50 minus 0, and displacement requires direction. This jogger was displaced to the east relative to where they started. Next, looking at terms related to how fast something is moving. I'll start with instantaneous speed. The variable is s. This is how fast something is traveling at a specific instant in time. Instantaneous velocity will be variable v. This is how fast something is moving, also at a specific instant in time, but now we need to factor in direction as well. Average speed will be s with subscript avg. This is how fast an object traveled over an interval of time. And then average velocity, v with subscript avg, also how fast over an interval of time, but factoring in direction as well. So speed does not factor in direction. Both of the first and third terms will be scalars. Velocity does factor in direction, so the second and fourth terms will be vectors. And all 4 of these terms should be measured in the unit of meters per second. Let's look at another real-world application. Every car is also equipped with a meter that tells the driver how fast the car is moving, and typically this is presented in the units of miles per hour. So which of the following motion terms is this meter presenting? Well, this meter is telling the driver how fast the car is moving at one instant of time when the driver looks, and is not calculating how fast the car is moving over any time interval. So I would have to rule out both of choices C and D. This meter also has nothing to do with direction. It is only about how fast the car is moving. So I would be choosing choice A, instantaneous speed. It is focused only on how fast and only at the instant the driver looks. Here are 2 equations that I think would be good to know. These are not typically included on class formula sheets. Teachers often expect you to know these. Average speed can be found by dividing the distance the object moved over the time that it moved for. We want to pair speed and distance because they are both scalars. To find average velocity, we'll find the displacement of the object over the time that it moved for, and we want to compare velocity and displacement because they are both vectors. The last motion term is acceleration, which will be the variable lowercase a. This is the rate of change in instantaneous velocity for an object. So mathematically, that can be expressed as delta v, change in velocity, over delta t, change in time. Acceleration is always measured in the unit meters per second squared. If you found this video helpful, then please consider hitting the like button and subscribing to my channel. You will help me reach more students. For more content videos, tutoring information, practice materials, and live review sessions, check out my website or follow me on my social media platforms.